Harmonic motion. In the following section, we will discuss simple harmonic motion of different systems. Mass attract to a string on a horizontal frictionless surface, the motion of a ball placed in bowl, and the motion of a bump attract to a string are example of SHM. Motion of mass attack in a string in SHM. One of the simplest type of oscillatory motion is that of horizontal mass string system. If the string is stretched or compressed through a small displacement x for its main position, it exerts a force F on the mass. According to Hooke's law, the force is given by F is equal to minus k x, where x is the displacement of the mass for the main position O, and k is a constant called the string constant, defined as k is equal to minus f by x. The value of k is measure of the stiffness of the string. Stiff string have large value of k and soft string and small value of k. F is equal to ma. K is equal to minus ma by x, or a is equal to minus k by mx. Proportionality A, proportionality minus x. It means that the acceleration of a mass attack to a string is directly proportional to the displacement from the main position. Hence, the horizontal motion of a mass string system is an example of simple harmonic motion. The negative sig in equation 10.1 meant that the force exerted by the string is always directed opposite to the displacement of the mass, because the string force always act toward the main position. It is sometimes called a restoring force. A restoring force always pushing or pulls the object performing oscillation motion toward the main position. And initially, the mass is at the rest is main position, and the resultant force on the mass is zero. Suppose the mass is pulled through distance x up to extreme motion A, and the release. The restoring force exerted by the string on the mass will pull it toward the main position O. Due to the restoring force, the mass move back. Restoring force decreases the distance from the main position and becomes zero at the O distance from the main position and become 0 to O. However, the mass gains speed as it moves toward the main position, and its speed becomes maximum at O. Due to inertia, the mass does not stop at the main position O, but continue its motion and reach the extreme motion B. As the mass move from the main position O to the extreme position B, the restoring force acting on it toward the main position strictly increasing in strength. Hence, the speed of the mass decreases as it moves toward the extreme motion B. The mass finally comes briefly to rest at the extreme motion B. Utility: the mass return to the main position due to the restoring